Hi everyone, and welcome to Tutor lessons. Today I'm going to be focusing on the second aspect of quadratics, which is things relating to the completing square. And today I want to look at maxima and minima for quadratics. Now, what on earth is a maxima and what on earth is a minima? So we're going to look at what these things are, and we're going to look at how we can determine them based on either using the completed square or another method that I have found recently. So just dive in. Right, so maxima and minima basically relate to your parabola's turning point. So if we take a look at parabolas, we can see we either have a happy parabola or a sad parabola. And that's just because it looks like a happy face or a sad face. And from this we can see that this particular parabola has a minimum point or a minima, and this particular parabola has a maximum point or a maxima. Now, these points are also known either by the term vertex or sometimes called the turning point. Most of you in the CAPS public schools will learn that the turning point form, which is a x plus p squared plus q, is how we use the completing the square to determine the turning point of our parabolas. But there is another method that is pretty handy, where we literally solve for the x value of our turning point, which relates to this. X is equal to minus b over 2a. So we take our values from our standard quadratic, which is y is equal to ax squared plus bx plus c, and we take these coefficients, sub it into this formula, and we can determine the coordinates of our maximum or our minimum. Now, to determine whether it is a max or a min, we need to understand what is our parabola or what is our quadratic. Is it a happy quadratic or is it a sad quadratic? Now, what determines this is the a constant from your quadratic. So this particular a value, if it is positive, therefore you have a happy parabola. And obviously if it is negative, then you'll get a sad parabola. Let's take a look at some examples on solving for the maximum or a minimum for a quadratic. So my first question is the following. Find the coordinates of the turning point for the following quadratic. And it is 2x squared minus 8x plus 5. So for this particular question, we need to understand, is it a happy or a sad parabola? And then from there, we can either make use of the x is equal to b over 2 minus 2a or the turning point form. So I'm going to use both methods here to determine the coordinates of the turning point. So the first method is using the x is equal to minus b over 2a formula, and so we're going to substitute in the values and see what we get. So x is going to equal to minus 8 all over 2 times by 2, so that's your a and your b terms respectively, so a and b, and this gives us an answer of positive 2. So that means that the x value of our turning point is 2, and now it's up to us to determine what is the y value. So therefore my y value is equal to 2 times by 2 squared minus 8 times by 2 plus 5, which gives me a value for my y to be minus 3. And so therefore my coordinate of my turning point is 2 minus 3. The other method is by completing the square. Now, if you haven't seen my video on completing the square using what I call the sneaky method, you should see a little pop-up above me now. Here is where I explain the sneaky method and the method that I'm going to show you in this particular video. So what we're going to do is we're going to convert this into the form of a x plus p squared plus q, where I'm going to manipulate this form and then do equating coefficients. So it's going to be a times by x squared plus 2px plus p squared plus q, and multiplying the ax squared plus 2apx plus ap squared plus q. And now we're going to relate these coefficients and solve for a, p, and q respectively. Right, so my first little equation, I can see straight away that a is equal to 2. Then next, 2ap must equal to minus 8. And I know what a is, it's 2. And here you can straight away see where this minus b over 2a form comes from. It comes from this very calculation. So p is equal to minus 8 over 4. So p is equal to minus 2. And then lastly, we've got ap squared plus q equal to 5. We know what a is equal to 2. P is equal to minus 2 squared plus q equals to 5. And so this is going to give us a value of 8 plus q equal to 5, leaving us with the value of q equal to minus 3. And so therefore my completed square form is 2 times by x minus 2 squared minus 3. Now from the completed square, we can find our turning point by having the negative p value and the q value from our completed square form, our turning point form of our quadratic. So if you're ever given the quadratic form of your parabola, then straight away you can get your turning point by just observing the values that you have. So from here we can see that our turning point is going to be minus 2, which is positive 2, minus 3. So these are the two possible methods of how you can find the coordinate of the turning point, i.e. the maximum or the minimum or the vertex of your parabola. I think the first method is quite quick and simple, but if you do happen to have a question that asks you to find the completed square form first, then finding the turning point from that is actually quite quick and simple. Once you have determined the coordinates of your turning point, our next job is to determine whether or not it's a minimum or a maximum. So if we have a happy parabola, right, we determine that that will have a minimum point. So therefore, if your a value from your standard quadratic form, so if your a value is positive, then you can immediately say that you're going to have a minimum. Your turning point equals a minimum. And then if your a value is equal to a negative, therefore your turning point is a maximum. I hope you guys found the video helpful. If you have any questions, please feel free to leave a comment in the comment section below. If you liked the video, please a thumbs up will be great, and a subscription to Forrester Tutoring will also be really appreciated. Thanks for watching. Cheers.